Hi, this is Chen from Deep Pathology. In this video, I'm going to show you my favorite demonstration in conferences. The reason that I like this demo is because it's super fast and it shows the main capabilities of the Deep Pathology Studio. The problem that we have is of a TCGA slide of breast cancer. What we want to have here is to distinguish between tumor tissue, necrosis, and stroma. So let's get started. In order to train an algorithm, I have to provide a few annotations of each category. Let's start with the tumor. So the tumor is the pink category. I'm going to make sure it's the right color. 1, 2, 3, 4, 5, 6, 7. 7 examples. Let's move on to the necrosis, the green category. So 1, 2, 3, 4, 5, 6, 7. The last category would be that of the stroma. It's the orange category. So let's provide a few examples of stroma. 1, 2, 3, 4, 5, 6, 7. Now in the studio, we always have the default background category, and basically it's everything which is not interesting for us. I'm usually just annotating a few examples of the background of the slide. So this is also like 7 examples. So we have 7 examples from each category. And as you can see, this is enough to kick off the training process of the AI solution. Now, just to make sure that everything is working well, we have the possibility to view how the solution evolves. What we have here are graphs of the F1 score for each of the categories. The F1 score is some kind of a mix between sensitivity and specificity. It should, in the best case, go to 1. And as we can see, the solution is actually being created, being trained as I speak. And we see that gradually the F1 scores is getting higher towards 1. So this is a good indication that the system is alive, kicking, and training. Okay, let's go back to the viewer. And what I'm going to do now is I'm going to deploy the current version of the AI solution to a region of interest. I don't expect it to work well at this point with so little training, but this is the starting point of our iterative training procedure. Okay, so as you can see, it's definitely not perfect, but it's also not too bad. So as you can see, the necrosis and the tumor areas are detected quite well, but the system is still struggling with the stroma. So let's just reapply the algorithm and see how it is working. This indicates that the AI solution is actually deployed on this field of view. Okay, so let's see what happens now. It still misses the stroma. So the whole idea with the studio is to fix the predictions of the algorithm where it makes mistakes. So for example, here I want to tell the system, now this is stroma area. So I'm overwriting the predictions of the current AI model. Let's just delete these. Okay, and this I have to correct as well. I don't have to correct everything, just to provide a few examples and check out what is happening to the graphs. So the system is actually digesting the corrections I have made, and it will try to improve the algorithm developed. So let's give it a few seconds to train again. and deploy the new version of the AI solution again on this field of view. Let's see if it has improved. I do see that I made a mistake here. I annotated necrosis in the wrong place, but I can correct it in a minute. Okay, so you see that actually the system has improved in the detection. So necrosis, tumor, and we see here the stroma in the middle. I do have to correct this and to tell it, yeah, this is stroma. So the system has to know that this is actually stroma. So as you can see, the system continues to learn from my annotation. It's an iterative process, and very quickly we are able to get a solid and good AI solution for the tissue segmentation problem. Stay tuned for our next video.